Welcome to the presentation of EO4CarbonFarming, a tool for monitoring, reporting and verification of carbon farming measures. I am Jakob Wachter and I work as a project scientist at the company Vista, which has developed this service. I hope you enjoy the presentation. The EO4CarbonFarming project is funded by ESA as a business application demonstration project, and it is now in its finishing phase, with all tests having successfully finished and the pilot phase being evaluated. The project relies on different sources of information as input but also as output data, such as farm and field information, climate harvest data such as the planting of catch crops, satellite data, especially Earth observation, carbon sequestration information such as the soil organic carbon content, and information about climate change, especially EU taxonomy, carbon market and sustainability measures. The goal of the service is to develop a MRV tool, which stands for Monitoring, Reporting and Verification of Sustainable Farming Methods and Carbon Sequestration using satellite data and a crop growth model, which is owned by the company Vista. And as already mentioned, this has already finished successfully, so the MRV tool can be used and has produced first results. The workflow is as follows. We get as an input, as already mentioned, satellite data along Earth observation data. This is GNSS data and meteorological data. They then undergo a specific pre-processing chain and are being stored to an offline data storage, and then used as input for the MRV tool developed by Vista. On the other side of the MRV tool, we get as an input from the customers via API or email information about their fields, and the output of the MRV tool, so the service results, are also being delivered back to the customers via API or via the EO4CarbonFarming cockpit, which has been developed in the project. Outputs of the service are, for example, the derivation of SOC content, soil organic carbon content, which you can see on the left in the map, and the monitoring, reporting and verification of sustainable farming methods such as crop rotation and carbon sequestration, and the verification of those measures, for example, with certifiers. As a first success story of the project, we performed a case study in Austria where we researched around 350 agricultural fields. You can see those on the map surrounded with the purple boundaries, and the map also shows the soil organic carbon content in the region, which we calculated for those fields but also for the entire region. We did this on 2 time steps, one being in 2017-2018 calibrated with in situ data, and the other one in 2022 and 2023. This allows us to perform a change detection of soil organic carbon content and to see the changes between those 5 to 6 years in the region. We can see in the reddish and orange colors fields where SOC content has declined, and we can see in bluish color SOC content which has risen in the fields. We then use this data to perform a more detailed analysis, especially on the fields we have researched where we know that sustainable farming methods have taken place. And on those fields we can see overall a clear rise in SOC content between 2017 and 2022, and we can also see that the rise is especially strong in areas where SOC content is rather low, between 0.8% and 2.4%, and where it is especially high, between 3.8 and 5.2% soil organic carbon content. As an additional layer of information, we then took the catch crop verification from the service. So we detected for each year in between the 2 measurements if there has been a catch crop planted on each field. So for each field separately we checked, has there been a catch crop, yes, no, or are we not sure. We then counted all of the field years where we have been sure that there has been a catch crop and correlated this against the mean SOC difference on the field, and the result is a very clear correlation of 0.9. So we can say quite clearly that the more years catch crops have been planted on the fields, the higher the buildup of soil organic carbon content on the field is. With this, I want to also show you the EO4CarbonFarming cockpit, where we can visualize all of the service results, and the users and the customers can use them. As already mentioned, the service outputs include soil organic carbon prediction service in relative and absolute values, catch crop verification and catch crop detection, verification of crop rotation, the carbon binding on the fields, and the monitoring and reporting of the development of catch crops. The latter we can see here on the map, with leaf area index being used as a proxy for the biomass status on the fields. And we can see this for each field separately, but also in the spatial representation and as a temporal representation via the calendar function, where the user can select different points in time to see the LAI status for their fields at this time point. During the season, we provide this information bi-weekly so that users always have a good overview of the processes on their fields. We can also select single fields via the field ID drop-down, and then for these fields see the temporal evolution of LAI values over the entire time. Users also have the opportunity to download data via the EO4CarbonFarming cockpit, and they can get more information about the services and a more detailed result overview for each field separately. I hope that this brief introduction into the EO4CarbonFarming service has been helpful to you, and in case of any questions, do not hesitate to contact us. Thank you very much for your attention.